the Physics Final Product Show. I'm Ethan Gershgorin, and this is my partner, John Stadler.
Today we are learning about our favorite summertime toy, the Frisbee.
Now, most people flick their wrists and watch their Frisbee fly away, but there's a lot of physics that goes into the perfect toss.
From college campuses to beaches around the world, you can't miss these flying discs. The first aspect of throwing a Frisbee is the spin. A Frisbee works very similarly to the wing of a plane. However, a Frisbee does not have the stabilization that the plane of a wing has. So, for the Frisbee to become stable, it needs to spin. The spin of a Frisbee turns it into a gyroscope.
This gyroscopic tendency forces it to stay flat. If the Frisbee was thrown without spin, the lift would cause it to flip over backwards. The key to a stable Frisbee is spin.
As you can see, the spin of a Frisbee allows it to stay stable and flat while flying through the air.
Conversely, when the Frisbee is not spinning, it cannot stabilize and flips over, as seen here. The second aspect of a Frisbee is the design itself. The design of a Frisbee is very similar to the wing of a plane.
The curved shape of a Frisbee causes the air to go faster on top and slower on the bottom. This creates a low pressure area on the top of a Frisbee and a high pressure area on the bottom of a Frisbee. This provides lift.
This is what makes the Frisbee fall slowly through the air.
Daniel Bernoulli proved in 1738 that as a fluid increases in velocity, it will directly cause a decrease in pressure. This is the reason that lift occurs on objects such as an airplane wing and, of course, a Frisbee.
The third aspect is the force of the throw itself. A Frisbee, in order to fly, needs to be launched transitionally with velocity. The faster the Frisbee spins, the more stable the Frisbee will be. Stability affects how far the Frisbee will travel. The longer the Frisbee stays parallel to the ground, the farther it will travel.
The force of the throw translationally also contributes to the distance the Frisbee will fly. Obviously, how hard you throw the Frisbee makes a difference. However, if the Frisbee does not remain flat, it simply won't matter how hard you throw it. As explained before, Ethan flawlessly tosses this Frisbee by putting horizontal spin on it so it can stay stable. He also exerts a translational force on the Frisbee, causing it to fly through the air. This is Bernoulli's equation. Very similarly to the conservation of energy, we can compare different aspects of fluids in order to find others. This equation consists of pressure energy, pressure per unit volume, and potential energy per unit volume. Basically, we're comparing energy per unit volume before and after, or in this case of a Frisbee, above and below. We didn't do an actual calculation because we don't have the equipment to measure pressure above and below a Frisbee, and it would be difficult even if we did.
In conclusion, there are three major aspects that go into the perfect toss. First, the spin. Without spin, the Frisbee wouldn't be able to stabilize while flying through the air.
Second, the design. Without a Frisbee's design, lift would not occur, and therefore it could not fly.
Third, force. The proper amount of rotational and horizontal force allows the Frisbee to fly through the air.
Thank you for watching the Physics Final Project Show. I am John Stadler, and this is Ethan Gershgorin.
Namaste.
We are going to learn about our favorite summertime toy, the Frisbee.
Now, most people just flick their wrists and watch their Frisbee fly away. There's a lot of physics that goes into the perfect toss.
From college campuses to beaches, you can't miss these flying discs.
I didn't know you were going to say that.
Like, how bad do you think it's going to look? You think it'll look terrible?
You mean when I fall on the floor?